Continue our ecology unit today with lesson number 8, the effect of human population growth and activities on the environment. So make sure you have your note taker out. It is 2 pages long, and we will get started now. Alright, so just something to think about here real quick. Look at this picture of our beautiful planet, and we share the Earth with millions of other species, as you can see here. But it just happens to be that we don't share very well. What are some of the activities that you see here that makes you think that we don't share this planet very well with other species? I can see a few examples here. So remember that in ecology, everything is connected to everything else. So what we do is going to affect other species around us. So what is the human impact? Humans and natural activities affect ecosystems on local, regional, and global scales. As the human population increases, so does the human impact on the environment. So we see that we are growing exponentially, right, until we reach our carrying capacity, as we learned in other lessons. So does that matter? Can we just continue growing exponentially out of control? Or our activities, are they going to affect the local and global ecosystems? So here are some examples of human activities that have led to a decrease in the capacity of the environment to support some life forms. So we are going to go over these 8 examples, and we're going to expand on some of them. So in your note taker, you have all 8 examples. So what you can do is, if there are things that I say that stick out to you, you might want to jot them down next to the activity. Remember that you can always pause the video if I am going too quickly. So let's start with the first human activity and how that is decreasing the capacity of the environment to support life form. So the first human activity that we see is deforestation. So deforestation is reducing the amount of forests. So we are going to focus a little bit on Virginia's forest land. We know that if we take away the trees, that's going to lead to soil erosion. It's going to lead to loss of biodiversity as habitat is destroyed. It's going to lead to climate change. So we know that Virginia has about 15.72 million acres of forest land, which is a decline of about 130,584 acres since 2001. 62% of Virginia is forested, which in 1940 only about 58 of Virginia was forested. So we see a little bit of increase there, so that's pretty good. But urbanization and development is the single biggest factor in the loss of forest land and acreage. Hardwood forests make up about 79% of all Virginia's timberland. Softwood forests make up about 21%. And private individuals own more than 66% of Virginia's timberland. The second human activity is the release of chemicals in the air. So within the release of chemicals in the air, we see that these chemicals can affect our planet in 2 different ways. So one of the ways is ozone depletion. So the ozone is this layer in our atmosphere that protects us from harmful UV rays. So ozone is known by the compound O3, so it's 3 oxygen molecules chemically bonded. So what happens to this layer of ozone as it becomes depleted? Well, then that means that more of the harmful ultraviolet rays from the sun can enter our planet, and it could cause harm to us. So what is depleting, or what started depleting the ozone layer? So we now know that there were some chemicals found in aerosols that are called CFCs, or chlorofluorocarbons. These chemicals would actually, they were involved in a chemical reaction with ozone, and it broke down the O3 molecule into just oxygen O2 plus a single oxygen atom. So the O3 was broken down, and you can see here in 1971, these were the amounts of ozone units in our atmosphere, right? And then we see that there was a big drop, right? By the year 2000, we were in serious trouble. Now we know that scientists started, becoming really alarmed, and the public started getting a little bit more conscientious of the problem of the ozone layer in the 1980s as we started seeing this sharp, steep decrease. But we were in serious trouble here as we were approaching the millennial. And we see here that this is an infrared picture of our planet. And we see here how this blue here is the ozone hole. Okay, so the more blue you see, the bigger the hole. So we see that the hole is actually closing up, which is a good thing. By the year 2065, if things go accordingly, right, and we continue limiting CFCs or chlorofluorocarbons into our atmosphere, we might get a renewal of the ozone layer. Okay. Now, again, all these laws and regulations are implemented by different countries, and we all have to come into agreement to make sure that these harmful chemicals are not put out into the atmosphere. Now, there are other chemicals that can be released into the air, and that could also damage our ecosystems. So pollution is another example. And here you see smog covering this city, which I believe looks like LA. And what is smog? Well, smog is an accumulation of carbon dioxide that's mixed in the air. And where do we get this excess carbon dioxide? Well, it mostly comes from the burning of fossil fuels. So then this carbon dioxide gets trapped in the atmosphere, and that's why it looks very blurry here. So we know that the more burning of fossil fuels that happens from cars and factories, the more carbon dioxide gets put out, and that increases the levels of pollution. We also know that there could be different types of pollutions, for example, from excess nutrient fertilizers. So if too many fertilizers are put into the ground, the nitrogen, the phosphorus, and the potassium can be washed away into lakes, rivers, and streams, and that could have other repercussions that we'll see in just a moment. Now, acid rain is also as a result of this pollution. So we know that this air being contaminated with CO2 can change the pH of rain. So when all these pollutants in the water cycle, whether it's the pollutants in water or the pollutants in the atmosphere, when all of these incorporate themselves into rain, it can cause the rain to drop its pH. So here we see that normal rain has a pH of about 5.6, and we see that acid rain has a pH of about 4.6. So when this rain drops to the ground, of course, that's also going to have implications on our trees, on our bodies of water, and all of this is a form of pollution. And all of this is affecting our biodiversity. All of this is affecting our planet, and it's all caused by human impact. All right, the other example of how we see pollution affecting our planet is through something called bioaccumulation. And this is when there is an increase in concentration of a pollutant in an organism, and the pollutant can be a different type of pollutant. So then what ends up happening because of this bioaccumulation is something known as biomagnification. So here's an example of a pollutant known as mercury, and how this pollutant becomes biomagnified from one trophic level to the next. So here we see an energy pyramid or a food pyramid, and we see that if the pollutant for some reason is found in the water, right, We see algae takes up that pollutant, and then algae-eating insects take up that pollutant, and then the insect-eating insects take up that pollutant, and we see just the chain keeps going up and up until it reaches humans. The really serious problem with biomagnification is that there is an increase in concentration of the pollutant. So maybe the amount of mercury here within the water or the algae was not as big as the concentration of the pollutant found here in the higher trophic levels. So this can become deadly to these organisms here at the top because they are taken in sometimes 5 times, 10 times as much of the pollutant that could be very deadly, right? So this can have an effect on these top consumers here. All right, so let's look at other threats to biodiversity caused by human activities. We know that intensive farming kills beneficial insects and plants. It degrades and depletes the nutrients in the soil it depends on. It creates polluted runoff and clogged water systems. It increases susceptibility to flooding. It causes the genetic erosion of crops and livestock species around the world. And it decreases biodiversity and destroys natural habitats. So the more that we grow as a population, the more food that we require, right? And the more lands that we need. And this becomes a problem because of the repercussions of this intensive farming. Now, because we need more land for farming, that leads to habitat destruction. So we see that woodlands and pastures are being converted to subdivisions. We're running out of room, space to live, and shopping centers, and we need roads and utility corridors. We need all these things to keep us alive, right? So we know that, which is the deadly or an urgent call to pay attention to here. It says that current estimates indicates that over 93,000 acres of Virginia's open space lands are converted into non-renewable uses each year. And this is very scary, right? Because imagine all the repercussions and the threats to the biodiversity, forest nesting of migrant birds, and so on. All right, another example of a human threat is eutrophication. And what is eutrophication? This is when a body of water becomes overly enriched with minerals and nutrients, which induces excessive growth of algae. So this process may result in oxygen depletion in the body of water called dead zones. And here is a picture of our beautiful Chesapeake Bay. And we see that there are already areas in the Chesapeake Bay known as dead zones, which are hypoxic, which means they contain low oxygen. And we know that organisms cannot live in low oxygen areas. So we see that a lot of the organisms that call the Chesapeake Bay their home cannot live in certain areas of the Chesapeake Bay. For example, the blue crabs. So when we put too many minerals and nutrients into our bodies of waters, and those are usually end up being there through runoff of fertilizers from intensive farming and habitat destruction, they all end up in the Chesapeake Bay. Another example of a human threat is invasive species, because we sometimes by mistake introduce non-native species to an area. So in the absence of their native predators, these invasive species bring disease, and they don't have any competition, and they will grow rapidly out of control, and they're going to exploit their new habitats. So new species have been arriving in Virginia from foreign lands since the settlement of Jamestown, and here we see some examples here of some invasive species here in Virginia, like the gypsy moth, the autumn olive, and the blue catfish. Overexploitation is another example of a human threat to our biodiversity. And overexploitation is the overuse of plant and animal wildlife by people. Also the excessive use of natural resources like fresh water, soil, or oil. So if we overdo it, right, if we are overusing our natural resources, then we run the risk of those natural resources from just running out. So for example, here are some examples of overexploitation of the Virginia deer. Good thing that they're coming back and being restored, and also overexploitation of the oyster population in Virginia, which again, we now know that they're making a comeback, which is a good thing, but we have to be aware that at any time, right, that delicate balance can be tipped either way. So we always have to be mindful of not overexploiting any of these natural resources. All right, moving on, we have climate change, and within climate change, we have other topics to discuss. And the first thing to point out about climate change is that climate change is not the same thing as weather. So, what does climate change mean? Climate change means that the average global temperatures are increasing. So, this means that if we take the Earth's atmosphere and we measure its temperature, since the 1900s, we see that the Earth has warmed by 1.5 degrees Fahrenheit. We've seen the 10 warmest years on record have all occurred since 1998, with 2016 being the warmest year on record. Climate change means that sea levels are rising. Global sea levels have increased by roughly 80 inches over the past century, and the rate of increase is accelerating. Climate change causes sea levels to rise in two ways. Either the ocean water is expanding as it warms, and land-based ice and glaciers and ice sheets are melting. And then we see that climate change also means that the sea ice is melting. We know that since 1979, Arctic sea ice extent in September, when we find the annual minimum has been reached, has declined by more than 30%. We also see that climate change is a precipitation pattern change. In some places, we're getting more rainfall, and other places are getting less rainfall. Nearly everywhere is experiencing more heavy rainfall events as warmer air is able to hold more water vapor. In the United States, the Southwest appears to be shifting to a more arid climate in which the Dust Bowl conditions will become the new norm. So we see that in different places like the Northeast, Midwest, and Plains, they have increased their annual precipitation by 5 to 20% during the last 50 years. And we also know that climate change means that oceans are acidifying. The pH of surface seawater has decreased by 0.1 units since 1750, and it is projected to drop another 0.5 units by the year 2100 if no action is taken to curb fuel emissions. And we know that our oceans are acidifying, are devastated for our ecosystems in our oceans, like the coral reef ecosystem. So, what are examples of climate change that we see here that are that have been um, whose impact has been increased by humans? So we see here two examples, which is the greenhouse effect and global warming, and we see how both of these examples have been pretty much exacerbated by humans. So here we see, let's look at the greenhouse effect first. So the first thing we need to understand about the greenhouse effect is that it is a natural process. We know that the sun emits solar radiation, and we need that, right? We need that for our planet to keep warm. So as the sun emits this solar radiation, it penetrates our atmosphere and it keeps us nice and warm, but we can't keep all of that heat. So some of the heat gets re-radiated back into outer space, and it escapes back into outer space. Now, the way that we're able to trap some of the heat in our atmosphere is because of naturally occurring greenhouse gases, like carbon dioxide, like water vapor, like methane. These are natural gases. So this is a natural effect. We want a natural greenhouse effect. This is what keeps our planet stable and habitable. But when humans enhance the greenhouse effect, that's the bad thing, right? So when we put out too much greenhouse gases in the form of carbon dioxide, in the form of methane, in the form of water vapor, then what ends up happening? Well, here comes again the solar radiation. Some of it gets re-radiated back into space, but not enough, right? More just remains within our atmosphere, and it doesn't bounce back into outer space. So then that means that that the temperature within our atmosphere is going to increase. And since the Industrial Revolution, the burning of coal, oil, and natural gases has emitted roughly 500 billion tons of carbon dioxide. Carbon dioxide is a greenhouse gas, and about half of which remains in the atmosphere. So if the carbon dioxide is just hanging out in the atmosphere as a greenhouse gas, what is it going to do? It's just going to trap all of that solar radiation, right? It's not going to let it escape, and our planet warms up. So the greenhouse effect, that is human enhanced, leads to global warming. And global warming is the trend of increasing global temperatures. So here we see the trend of how our temperature has increased. So here you see it in blue. Now, from 1960 to 1990, we see that the temperature has fluctuated up and down, right? There's nothing wrong with temperature fluctuating up and down. But notice how CO2 is also fluctuating up and down along the same line of temperature. So we know that there has to be some sort of correlation between the carbon dioxide concentration and the temperature of our planet. Why is it that as the CO2 concentration goes up, so does the temperature? Okay. And we know that, if we keep increasing the global temperature, what's going to happen to these polar ice caps? We see here that they're starting to shrink, they're starting to melt, and that's not a good thing because you're dumping. Well, first you're losing habitat, right, for that ecosystem, and then we also dump a lot of fresh water into our salty oceans, and that disrupts ocean currents, which leads to more disruptive weather patterns. So here we see a historical change in the carbon dioxide concentrations, because historically CO2 has fluctuated up and down, right? That is a normal trend. It has fluctuated up and down. And some climate change deniers use that as a talking point, saying, well, CO2 concentrations have always changed historically. And that is true. They have always changed historically. But if you notice from this graph is that they've never fluctuated higher than 300 parts per million. This is the part they tend to leave out, right? So it wasn't until the 1950s, right, that we saw a look at this sharp increase in CO2. And this is where bells start ringing, right? And scientists start saying, well, wait a minute. If historically speaking, right, we've never had a CO2 concentration higher than 300 parts per million, then how come this is shooting up right here? This is something that is worthy of an investigation. This is something that needs to be taken a look at, right? Because now we have almost, well, at this point, right, almost close to 420 parts per million of CO2. So what is happening here? And by the way, the way that scientists are able to measure the amount of CO2 is through ice core data. So scientists are able to measure the CO2 that gets trapped in ice cores, and then they're able to tell how much CO2 was in the atmosphere a long time ago. So today we see that, notice here that CO2 parts per million are increasing, and today's CO2 levels are somewhere around 415 parts per million. So, what is causing this CO2 level to increase? Okay, what is causing this sharp increase? And we can all agree that the CO2 that is being released by the burning of the fossil fuels is what's causing this sharp increase, right? So it just if we remember historically, since the Industrial Revolution, right? When was the Industrial Revolution? It was around this time, right? So here we see a sharp increase in CO2, all the fossil fuels burning, releasing CO2, and then we see the CO2 traps all the solar radiation, and we see that that has a correlation in temperature. Okay, so we need to be aware that climate change is real and that it does have a human effect. All right, guys, so in your note taker, make sure you've written down the steps in the greenhouse effect and what it is that happens, and make sure that you study the relationship between the temperature and carbon dioxide in the atmosphere. Okay, that's it for today.